Hello all, let's work on the section 14.1. This section tends to be on the easier side, and toward the end later on you will see I cover some material that I didn't cover in my original lecture because it's just too easy, okay, about the idea of level curves and the idea of contour math. Okay, but you will see at the beginning it tends to be on the easier side. So number 10a, what is the value of the function f at 3, 1? We plug in that coordinate. Oh, I just realized that this function is independent of x, huh? Is it right? Yeah, so if you imagine the graph will be a cylinder, is it right? Parallel to x-axis. Is it right? Okay. Part B, what is the domain? The domain is all xy, where the y must satisfy this, right? 4 minus y squared greater equals to 0. But we know 4 minus y squared, if we have y here, and then has to be greater equals to 0. So it must be from negative 2 to 2, huh? Okay, from negative 2 to 2. So we can say that the domain is all xy where the y is between negative 2 to 2. If we sketch that, on the number line or coordinate plane, it will look like this. So the y is between negative 2 to 2, but the x is everywhere. Okay. Okay. Yeah, we can also write it this way though. This is actually r for the x component by negative 2 to 2. You can also write it in that notation. Okay, and then how about the range of f? The minimum for 4 minus y squared under square root, the minimum is 0, right? It's when y negative 2 or 2. And it is maximum when the y is 0. Okay, so the range will be because of that plus 1, right? The range will be from 1 to 3. Okay, that's for part C. And then number 10 part C. Number 12 part A. Evaluate G1 to 3. G1 to 3 will be 1 cube 2 squared times 3 square root of 10 minus 1 minus 2 minus 3. That is 1 times 4 times 3 times square root of 4. That's 24, right? 12 times 2, 24. Okay, now part B, what is the domain of G? Of course, under square root, we need 10 minus x minus y minus z to be at least 0. In other words, x plus y plus z will be less than equals to 10. Okay, so it's a plane, right? The boundary is a plane. The boundary is a plane. If I try to sketch that, the x, the y, the z intercept. Okay, of course, not only this triangle though, but if we look at the first octant intersection, it will look that the boundary is, okay, and 0, 0 is in that domain, right? Okay, so you can imagine this is the domain is all x, y, z, where x plus y plus z is less than equals to 10. Okay, this is the region If we try to describe that in words, this is the region or the space at or below the plane. X plus y plus z equals to 10. Okay, the region bounded below or at bounded by x plus y plus z equals to 10. Okay, you will see that the emphasis on this section actually on the domain and the domain of a multivariable function. Okay, and the extra material that they teach at the same time is what they call contour map and level curves. Okay, sketch the domain of the functions. Of course, this one we need x squared minus y squared greater or equals to 0, right? Which if we graph this, it is actually, let's see the boundaries. The boundary will be x squared minus y squared equals to 0. You will see x equals to plus minus y, or y equals to plus minus x, which is basically this part here. Okay, now the thing is I need to do testing points, right? But if I test the points, I will see that the region actually here, right? If this is x-axis, this is y-axis, that will be the region. Okay, this is y equals to x, and this is y equals to negative x. Okay, we test point, test 0, 1, 0. Of course, we need to test a coordinate not on the boundary. And then the third step, we get that region. Okay, let me move it here underneath. Okay, and then number 20, find the domain of this arc sine. Now arc sine, the domain for arc sine is that blah has to be between -1 to 1, right? Okay, in other words, we have x squared plus y squared minus 2 has to be less than equals to 1 and greater or equals to -1. In other words, x squared plus y squared is between 1 and 3. Okay, in other words, the radius is between 1 and radical 3 if we see that from polar coordinate system point of view. So the domain looks like the region bounded by two circles, radius 1 and radius radical 3. Let me use another color. So this will be this region here. Okay, that's for number 20. Okay, now in this number, let's do number 46. Okay, I try to pick a good one, an easy one. Okay, number 46 seems to be harder, but it's actually on the easier side. Now, of course, then for number 46, you will see that the domain is given by all x, y, where x squared plus y 4y squared is at least it's actually strictly greater than 0, right? Okay, in other words, it's basically all the whole plane except the coordinate 0, 0. Is it right? If you think about it. Okay, everything's okay except 0, 0. Now level curves is basically doing the following. notice they say the several level curves, right? So you see, suppose when I choose, oh, by the way, from here you also see that the range is basically negative infinity to infinity, right? Because if this is very, very close to zero, that natural log of near zero is negative infinity. Okay, very close to negative infinity. Now, what I want to say is when they ask us to graph a level curve, several level curve, you basically pre-decide some z, some number, some value in your range. Let's say, let's start with z equals to 0. When z equals to 0, okay, when z equals to 0, what will the curves look like? You see, so basically you cannot like imagine this function will give you a surface, right? It will give you a surface. Maybe something looks like this. Let's say give you a surface. Now then when you say level curve at z equals to 0, you basically take, okay, when you cut that with a plane z equals to 0, when you cross section this with z equals to 0, what is the intersection of z equals to 0 to that curve, that surface look like? Oh, in this case, maybe it looks like this. Okay, now later on when you cut it with another level curve with higher z, for example, then what is the intersection? Then you get this, let's say. Okay, now the contour map is, if you see that from above, okay, if you see that from above, this is the contour map at, let's say, c equals to 0. This is the contour map, and from c equals to 1. Yeah, contour map is when you put those, if you put those level curves together and see the intersection at once. Now, my explanation now may not be that clear, but if you ever had what they call MRI or CT scan, okay, MRI, take a look. Yeah, try to find out what is MRI, what is CT scan in medical field. MRI, magnetic resonance imaging, or CT scan, computer tomography scan. Okay, yeah, try to find out. Okay, then you can have a better figure. It's basically, let's say they do the CT scan or MRI on my head, right? So let's say this is my head. The way they take the picture is they take the slices of my head, the picture of the slices of my head. Okay, and they present that per slides. Let's say this is slide number 1. The intersection looks like this. Slide number 2, the intersection is bigger. Slide number 3, the intersection is smaller. So let's say it looks like this, and then this, and then this, like that. Okay, now the thing is, what this contour map doing is like put all these three pictures together. Like that. Then you suddenly have contour map. Okay, yeah, but let's put it in practice for this question here. Suppose z equals to 0, then we get natural log of x squared plus 4y squared equals to 0, which means x squared plus 4y squared equals to 1. Now, what is the graph of that thing look like? The graph looks like the x component is 1, the y component is 1/2. Okay, so let's say this is what it looks like. Okay, it's an ellipse, right? This is 1, this is 1/2. Now let's go on to the next level curve. Let's say when z equals to 1, natural log of x squared plus 4y squared equals to 1 means x squared plus 4y squared equals to e. And what is the level curve? The level curve will be, I think we stretch that by factor of square root of e, right? So it gets larger. Okay, this is square root of e, and this is square root of e over 2. Okay, if we do z equals to 2, for example, then we have natural log of x squared plus 4y squared equals to 2, which means x squared plus 4y squared equals to e squared. Okay, and you see that the curve is actually even larger in this case. Not always true though, but I basically what I'm doing is I'm graphing this. This is x over e squared. This is y over e over 2 squared plus 1. From there we see that the graph has, let's say this is e, and this is e over 2. Okay, now then later on, those are the several level curves, right? Now then if I put them together later on, it will look like the following is the contour map. Okay, the following is the contour map. I basically put all those three graphs together in one plane. This is when c equals to 0, and then z equals to 1, z equals to 2, like that. Okay, now let's try to present this or view this from our picture. Okay, so if I use GeoGebra to graph the 3D, okay, we start with c equals to natural log of x squared plus 4y squared. So that's what it looks like, right? Now if we want c equals to 0, okay, what does the curve look like? We'll see from above. That's what the curve look like. Okay, that ellipse there. When c equals to 1, that's what it looks like. Now let's change the color. Let's change the color. Change the color to maybe yellow. Okay, so now you see, we basically cut that curve from different height, right? And then you see the one at the bottom is in light blue, and then the one on the top is in green, in yellow. So if we see that from above, from below, you see the level curve. These are the curves when c equals to 0, and this is the curve when c equals to 1. Let's go on further when c equals to 2. That's what it looks like. Let's change the color. Make it what? Maybe light red. Okay, so that's what it looks like. Notice that basically that curve being cut by three level curve, 3 flat z equals to constant curves. Okay, and the one we see on the top, of course, the c equals to 2. Okay, the one we see at the bottom is when c equals to 0. Okay, and the middle one we saw earlier, the yellow color, is the c equals to 1. Okay, let me screenshot this. And then put it back to my notes. Okay, so this is when c equals to 2, c equals to 1, and c equals to 0. Okay, but when we see that from above, the intersection actually have this kind of curve. Okay, now the problem is that later on, our textbook will give you this contour map and then ask you, as the z increases, where does the graph going? Is the graph actually increases as z increases, or if z increases, you see the graph, the contour map is actually growing, right? Which means as u increases, the graph is actually getting larger and larger. Now, you can imagine if I reverse the order, like let's say this is c equals to 2, and then this is z equals to 1, and this is c equals to 0. Now, it means at the bottom, it's larger and then gets smaller and then gets smaller. And then when you compute kind of like put the graph together, then you will see it actually looks like this, right? Okay, the higher you go, the smaller it is. Okay, let's do one more example. Which one I think I like? I want to choose an easy one too. Maybe number 49. I think that's another reasonable one. Okay, so what is the domain? The domain is all x, y, where y squared minus x squared is greater equals to 0, right? And from there we see that the range will be everything but, I think the range will be non-negative, right? The range will be non-negative, but this is the domain. Because the range is non-negative, then our z for the level curve that we choose cannot be negative number. It's different from this one. This one you can choose your z equals to -1, and you will see a smaller level curve. Okay, z equals to -1. For that question, you will get an even smaller one. Okay, you will see even smaller one. I think that will be 1 over square root of e here, and this is 1 over 2 square root of e here. Okay, even smaller one. Now, but for this guy, because the range is 0 to infinity, then we will not use level curve negative. Okay, so it does have something to do with the range. So when c equals to 0, when c equals to 0, 0 equals to square root of y squared minus x squared. That gives us y squared minus x squared equals to 0, which means y equals to plus minus x. That's basically the boundary we have, right? So the level curve are is this. This is when z equals to 0. Now, and then what happened when c equals to 1? So 1 equals to square root of y squared minus x squared. That's y squared minus x squared equals to 1. Oh, that's a hyperbola. Huh? It's hyperbola. Okay, and then what happened when c equals to 2? Which means y squared minus x squared equals to 4, right? And the hyperbola is, I think it's even larger, right? Like that. Okay, which if I put the contour map together, you know what? Let me make it a bit thicker. If I put the contour map together, then I will get something looks like this. This is the following is the contour map for the level curve for z equals to 0. Okay, and then when c equals to 1. And then c equals to 2. Okay. And of course, we can see that better, even better, if we look at that from GeoGebra. Let's take a look. From GeoGebra, let's see, z equals to, let me change this here, square root of y squared minus x squared. And then we get, let's see that from far away. Let's see that from closer then. So if we see that from the side, it looks like this. Right? That's what it looks like from the side. This is the z equals to 0, the yellow one z equals to 1, the pink one is z equals to 2. If we see that from above, I think this is actually a pretty good picture. I need to rotate this. I'm sorry. This is the regular view we have, right? From the first octane. Then if I see that from above, I want to rotate. Okay, so if I see that from above, this is what it looks like. Okay, this is what it looks like. So you see this, the x equals to y and x equals to negative y. It's not really nice, huh? And then let me get rid of this for now. Oops, not good. I don't like that graph. So what happened is, which one I want to get rid first? So, oh yeah. So if I see that from above, you will see that this part here is when the surface above the z equals to 2 is, I think I should say below, huh? Okay. Yeah, so let me get rid of this first. No, I don't see what I want to see though. Is it better if I see that from below? Maybe if I see that from below, that's what it looks like. Still ugly, huh? Let's see. I'm sorry. I still don't get super used to play with GeoGebra yet. But I hope this view is better. I hope this view is better. If something looks like this, right? Yeah, if we see it this way, maybe it's better point of view. Okay, let me screenshot that. And then put it in my note. Make it a bit smaller. Okay, so basically I want to say that the top one that we see here, the one that we have here, this guy here, this is the level curve C equals to 2. Okay, and then if we go down, this is the level curve C equals to 1. That's the level curve C equals to 1. Sorry, that's not there. I think it's somewhere around here. Oh yeah, that's right, that was right. That's level curve C equals to 1, and also the one here. It's kind of hard to imagine that. It's C equals to 1, and this one here is when C equals to 0. It's a straight line, right? It's C equals to 0, like that. Which, if we see from above, it looks like this. Okay. Of course, you can see it's not easy to graph, right? So that's why I don't really want to spend this on during our class time. Okay. You may want to do it yourself. Try to do some problems yourself. Okay. That's for it.